Welcome back. This is the third and last video recording for day 5. This should be a very short video. Okay, so where I've left you off is with this complex number here in standard form, and I would like you to give me the polar form of this complex number here. So how do I do that? I need to figure out what r is, and I need to figure out what theta is. Alright, so how do I find r? First thing I need to do is I need to do a quick sketch so that I can figure out where it is located. -4, that's my A, and this is my BI, right? So -4 is, let's just call that -4. +5 will be here, or I'm just going to call it that. So it's going to be -4 plus 5i. So it is in quadrant 2. So keep that in mind. R is going to be equal to square root of a squared plus b squared. So that's -4 all squared plus 5 all squared. And that is 16 plus 25 square root of, and that is square root of 41. So I figured out what R is. Theta. Theta is always inverse tangent of b over a. Okay, and if you ever forget, it's the opposite over adjacent is tangent. So inverse tangent is going to give us the angle measure. So, and that is going to be inverse tangent of B is 5. And -4 is my my adjacent side. Okay, so now important thing is, okay, so here I'm asking you to give me the angle in radians. So important thing is currently this calculator is in degree mode. You do need to change that to radians so that it's going to give you the radian measure. Okay, so I need to change that to radians now. And so then I do 5 divided by 4 is equal to, that's 1.25. And I am going to second tangent. Okay, depending on the calculator, some calculators will require you to press the inverse tangent first, followed by the number. Some calculator you will need to type the enter the number first and then press the inverse tangent. Okay, so this calculator is actually requires me to enter the number first and the inverse tangent. Alright, so then this tells me that this is 0.8960. Okay, so this is a very small number. So I would like at least 3 digits, maybe even possibly 4 digits. Okay, so theta is 0.89 over 0.9 radians. 0.9 radians is close to pi is 180 degrees. And we're really talking about, let's just check that. Okay, so if I was to change that to degree mode, and what angle is that going to give me? So 5 divided by 4 is equal to, and inverse tangent is giving me 51 degrees. Okay. Now, the radian that it gave is really the first quadrant angle measure. Okay, so this is 0.89 radian. Okay, but we don't want that. We want this angle measure, right? So how do I figure out that angle measure? Well, it's going to be pi minus 0.89. Okay, so this is my reference angle, and so that reference angle is going to be same as this reference angle. So we need to subtract from pi. So our actual angle measure theta, so that's my reference angle. Theta is going to be pi minus 0.8961. So now we are going to change that to radians. Okay, so 5 divided by 4 is equal to, and then inverse 10. That's okay. So, and I need to subtract that from pi. So what I can do is I can subtract minus pi from it and take a negative of it. So it's going to be, theta is going to be equal to 2.2455 2.5 radians, or 2.446 will be sufficient. Okay. Alright, so now that I have radians and the angle measure, or radius and the angle measure, I can say what is my polar form of this complex number. That's going to be r, which is square root of 41, multiplied by cosine of theta, which is 2.246. And notice I'm not putting the degree symbol because we are dealing with radians. And I sine of 2.246. And that is going to be my polar conversion of the standard form of the complex number. Okay, that's it for today. Thanks for listening.